Hello, everyone. This is Colleen Milton, and on behalf of Anodot and 451 Research, I would like to welcome you and say thanks for attending today's webcast titled, Use Autonomous Analytics to Thrill Your Customers. Leading off the discussion today will be Nick Patience, who is Founder and Research Vice President at 451 Research. Following Nick will be Tyler Pines, who is Principal Escalation Specialist at Appnexus. And following Tyler will be Ira Cohen, who is Founder and Chief Data Scientist at Anodot. Just a few quick housekeeping items before we get started. To ask a question, simply type it in the question box on your screen below. We will answer as many questions as we can during the Q&A session, and we'll respond to all unanswered questions via email after the webcast concludes. This presentation and slides are available for download. And finally, please provide feedback at the end of the webinar. And with that, I'll turn it over to Nick.
Great. Thank you, Colleen. So, hi everyone. I'm here to kick things off and talk about analytics and machine learning before handing over to Tyler from Appnexus. And so, what I wanted to sort of set the scene by talking about is how organizations that we deal with on a daily basis are seeing the need to become much more data-driven, and with that comes the need for analytics. So. Most companies that we come across are increasing their investments in data processing, in analytics, and in machine learning with a desire to ultimately become more data-driven or entirely data-driven. That's because data is a key driver enabling companies to grasp opportunities presented by digital transformation and thus gain some sort of competitive advantage. We do a survey every quarter called Digital Pulse. And it's kind of high-level skimming across our entire survey base of about 60,000 IT and line of business professionals. And we ask them at the end of the year, last year, and the end of every year, we ask them what their top priorities are for the following year. And as you can see here, the top three priorities, business intelligence, machine learning/AI, big data processing engines, are all data-driven. They're all data-driven priorities. And so that's what organizations are telling us, so that their priorities for this year, obviously we're halfway through the year now, but that's certainly what's been setting the agenda. And then if we look at the two questions here, there's a crosstab of the same question in dark blue, supplemented by what is your level of usage within these organizations of the following technologies. And you can see BIs and analytics obviously been around for a while. Machine learning's much more nascent, and big data is certainly something people are using. But there's a lot of pent-up demand for technologies that can leverage data to find insights. So what are some of the specific goals? What are some of the things that people at organizations are trying to do? Well, they're looking to take advantage essentially of new data sources and combine that with information they already have about their customers and the other parts of the business to develop new innovative applications and services, as well as look for operational efficiencies. And so in terms of some of those new revenue opportunities, I mean, one of the leading use cases overall is IoT, combining data from devices, from sensors, from their customers even if they can, and analyzing that in real time or near real time to react better and faster by leveraging things like location-based services. They're also looking to move into adjacent markets. So, for instance, a lot of product-focused companies are looking to sell predictive maintenance services on top of that, so they can obviously generate more revenue from their customers, but have a deeper relationship and a much more longer-term relationship with their customers as we move to a more subscription-based economy, if you will. And also accelerating time to market. So, for instance, identifying the most valuable customers and launching special programs to boost loyalty. Other revenue opportunities like that. And then on the improving operational efficiency side, that they're varied. Obviously, depends on the kind of organization you are. And if you're in a regulated industry, there's a lot of internal processes to be automated. Supply chain is an enormous source of data, and one that has been until quite recently quite manually driven. I think there's a lot of opportunities there. And obviously, in marketing is almost entirely really data driven, and the quest there to get the ultimate kind of personalization down to the power of one is a very data driven movement. analytics and tools like that have been around in various guises for a long time, but they're not all the same, and they've developed over time. So if you look from the bottom left, where we have reporting, where in days gone by it might take IT 3 months to generate a report, we're moving into statistical modeling, and as you can see here, as we move to the right hand side, the business value is increasing as analytics becomes more important strategically. And then we add machine learning to the mix, and we get predictive analytics trying to predict what's going to happen. We get descriptive, describing what's happened, and ultimately we can get to prescriptive analytics, so influencing what happens in terms of suggesting how a business analyst or a user like that should use the data and give them insights so they can actually influence their actions. So let's just look at machine learning for a second here, just to skip through this one, which is a definition. So machine learning is a subset of AI. We're not going to spend any time on the differences between the two because it's not relevant here. But the thing I like to think about, what is the primary value, what is it that machine learning can bring, machine learning driven analytics specifically can bring to an organization, that is spotting patterns. Spotting patterns in large volumes of disparate data that a human being on their own could not otherwise spot. Another way of thinking about it is as a force multiplier. With these numerous data sources coming at you, even if you're not in a kind of industrial IoT setting or in something more specific, there's still the ability now to pull in unstructured data sources in ways that you couldn't do before and combine them with structured data sources. If there's only one person there with 2 eyes and a brain, that's a lot of work for them to be able to parse that data and understand it. Machine learning driven analytics is a force multiplier. So if you put in this model here with the first ever tank used in World War I, if you put four soldiers in that, they suddenly become a hell of a lot more powerful than they would have been if they were trudging through the mud in Northern Europe, as it were. But in the same kind of metaphor applies here. There's lots of very powerful tools you can put, even if you're only in the hands of your team, even if you only have quite small teams. So we've done, in addition to the survey I showed you at the beginning, we are just about to publish the first of our what we call Voice of the Enterprise surveys focused on AI and machine learning. You literally are the first people in the world to see these slides because we haven't even published all these to our customers yet, and I'm not going to go through the whole survey, obviously, but just want to pick out a few interesting points that back up the kind of data-driven story. Just to start off, we asked everybody in the survey, a very large sample, how important they think AI and machine learning is, and only 3% of them didn't think it was that important. 97 thought it was somewhere between slight and significant impact on society in the next 2 years. And we asked them much more detailed questions about their roles and all that kind of thing. We're not going to get into here, but suffice to say, it's a very, very important subject. We asked them, what is the main use case you're using for AI and machine learning? And lo and behold, the largest single use case is business analytics, and we're going to break down in a second what that means. But business analytics was the single most important reason for using machine learning by a third of the respondents. Security was there, sales and marketing also, and those two use cases are also very analytics driven. Security is being revolutionized, is probably putting it too strongly, but changed and transformed by the use of analytics. And sales and marketing has always been a prime use case for that. So we asked them, what do you mean by business analytics? If we break down that group, that third there in a bit more detail, forecasting is the primary use case. People want to be able to predict the future, whether that is sales or production or inventory or the weather and things like that. They're also using analytics to enhance workforce utilization, productivity, optimize processes, predicting mechanical failures, preventative maintenance. Obviously, a lot of manufacturing companies, as I mentioned earlier, are looking for service opportunities there, and they're using analytics for that. And then logistics and other forms of forecasting and analytics are other use cases. One thing we asked the cohort also is, what is stopping you here? What is the single biggest barrier? And perhaps not surprisingly, it's not enough skilled resources, not enough skilled people. Now, going back to my force multiplier metaphor, the only way really of getting around that, unless you suddenly come into have an incredible quarter or incredible year and you can hire tons of people, is buying the right technology. And even if you do, even if you are able to, hire tons of people, you can make them so much more productive with the right technology and the right tools. One interesting point there is what is not holding people back is lack of support from senior leadership. Only 2% cited that as a principal barrier to using machine learning. So there's nothing really stopping companies. There's no remit from the top that's stopping companies adopting this kind of technology. So I just want to look at a few use cases before I finish my section. This is if I'm asked one question more than I'm asked any other question, it's this kind of thing. Companies think they hear lots of stories about Google and Facebook and Amazon and those companies that have massive data sets on our intent, on our buying patterns, on our social patterns, and they don't think they have anywhere near enough data to do anything interesting with. That's simply not the case. There is always something can be done, and I often caution companies not to look for the single thing that's going to transform their entire business. They can look for narrow use cases that on a incremental basis can change things. So there can be very, very a lot of the use cases I see around machine learning driven analytics at the moment, and probably for the next couple of years, are quite narrow. I mean, they're very specific things. It might be understanding a next best action for a sales team or something like that within a specific customer segment. But that's fine. That's totally fine. So, but ultimately what this kind of technology enables you to do is answer more complex questions than you could. Questions like these: so, is there an abnormal amount of traffic coming from particular hosts? Can you scan your network automatically and spot patterns that you may never have seen before? How can I take advantage of my competitors' problems today? And the emphasis there is today. Timeliness. It's not can I react to something in 2 weeks' time? Is the user accessing resources they do not normally access? Again, you're looking for anomalies there. Why did that batch get put in a different vehicle from the rest? As we get further down the line, for instance, machine learning and image recognition, then cameras will be able to spot patterns in certain situations that if you're on a sufficiently large scale on a logistics organization, one human in the front of a set of screens can't possibly spot. Why is that widget a different shape from the others? Again, a kind of visual, a visual metaphor here, but something as we progress in machine learning, we'll be able to turn that into an analytics application. And how much more stock will we need if this weather pattern continues for 3 days? So pulling in different data sources, weather in this case, and in answering a question over the next 3 days, we're answering the question now. So very compressed time frames and being able to react extremely quickly, and that's one of the advantages of this. So we think overall, just in summary, that organizations need to become more data-driven to respond to the pace of change. There's lots of cliches around the pace of change has never been never been as fast as this, and it'll never be as slow again. And there's certainly something to that. I've been in this job essentially for 20 years, and I've never seen it sort of transform like this quickly. And I think we're going to hear about a couple of use cases now, but there's certainly an enormous amount of opportunity here. So with that, I will hand over to Tyler from Appnexus.
Great. Thanks a lot, Nick. So hey, everyone. As Nick said, my name is Tyler. I work on the Appnexus team. You could think of me kind of as the product and developer lead for our use case of Anodot over at Appnexus. And this is a presentation that's going to talk a little bit about how we managed to thrill some of our customers using the Anodot product. So just a little bit on Appnexus. We're a cloud-based digital ad company. We're based in New York City, but we have offices, I think, over 25 at this point around the world. We service all sides of the ad market with a number of features on the DSP side, the sell side, data management, yield management, financial clearing, etc. A note on scale, just to sort of give a context for the challenges that tech companies face when tackling machine learning and other analytics. Back in 2013, we were looking at about 28 terabytes of data per day that we had to process into analytics data and other data sets that we present to our customers for usage. That's about 1 million max QPS, which is essentially impression events, ad events per second, which came out to around 40 billion a day across 3 data centers. This year, we're looking at almost 10x, depending on how you look at it. 250 terabytes a day, 7 million max QPS, 340 billion impressions a day across 7 data centers with around 5,500 servers as of a couple of months ago, I think is when I gathered these numbers. And just to put that in context of scale, the Library of Congress is somewhere around 10, maybe in 2018, 20 terabytes of digital data in total. So we're doing about 25 times that every day. And these numbers are not surprising to people that operate at internet scale, but for folks who don't, they can be pretty eye-opening. A number of years ago, Appnexus made a shift from dealing with largely remnant inventory on the internet, which is a term that the industry uses for second view, third view, or pages that are more deeply buried in the internet, to more premium advertisers, marketers, sellers, front page, etc. And with that came more responsibility in terms of our monitoring and our desire to thrill these customers with higher expectations. Some of those I listed here. They expect us to catch problems on our platform, and they don't particularly care if we cause those problems or they cause those problems. If they impact their revenue, there's something that we need to address. We also found that even despite our internal rigor around incidents, the customers didn't at least perceive a benefit from our internal classifications, because we made some attempts to share some of those higher level classifications with our customers in our communications and didn't necessarily see a whole lot of benefit. The proof was really in the pudding, as they say. So in tackling these new high level goals, we decided that we wanted to be the type of company that caught our problems first, regardless of who or what caused them. And in doing so, we wanted to give our customer-facing teams better and more proactive visibility into what's going on with their customers day to day, instead of waiting just to react to customer support tickets, calls, etc. A couple of notes on challenges in terms of traditional monitoring. If there are any engineers in the audience or people who have experience dealing with systems, you may recognize the screenshot of the open source Grafana tool that we use at Appnexus for a number of our monitoring needs. The problem with these tools is typically within their normal use case bounds, you cannot really deal with seasonality very well, which is a massively consistent challenge in the ad market, as when users across the world sign on to their computers and mobile devices and so forth, you see a huge rise and fall in activity levels of ad impressions across the world. And you can see the levels are the highest when the various geographical regions align. And that's something that static thresholds, even with some fancy math, that can be really challenging to take into account intelligently. Even more challenging in the internet world is, especially in advertising, you have inconsistent orders of magnitude for certain types of business activity that's totally expected. So this is just another screenshot of the activity of one of our customers, one of their business objects. You can see that they had a fairly spiky cost curve over here on the left, and then on the right, it really evened out, but to a much lower order of magnitude. And that can happen if they, for example, on the buy side, if they get an order with a marketer, they put in the details, and the spend over a certain amount of months is at a fixed rate, and then if maybe they're not successful, and the next quarter the budget goes way down, and so you see a drop. Could be the reverse, where the budget goes way up, and all of a sudden, boom, you see this skyrocket, and you have essentially a new normal. And if you don't have machine learning or something that's going to do this in an automated fashion, you're going to have to change these thresholds manually. And of course, across thousands of customers with thousands of business objects, that becomes completely untenable. So when we were introduced to Anodot, we began our relationship with a trial. We wanted to look at the Anodot capabilities. We wanted to expose some of the product to our customer teams. And we wanted to make sure that Anodot could meet the needs that we have and that we would be a good partner for them. So we're trying to look for a number of things. Obviously, issues that Appnexus has, technical or otherwise. They could be incidental, occurring in a moment. They could be release related. We also care about mistakes that our customers make. We want to be the ones that catch those, even though they make them. Problematic market dynamics is an interesting one. For folks who do any work in optimization and machine learning, you probably are aware of slow leak type problems where it's possible for algorithms to grow slowly, more and more incorrect in their predictive abilities, and that can be very hard to catch. And just generalizing any impacting behavior on our customers' revenue that we would want to know about that might even be expected, like I mentioned the large order ending. That still might be something that our salespeople or somebody else wants to know about. So over the course of the last couple of years, we've had dozens and dozens of catches, big and small. Here's just a couple of highlights. I try to get some variation here, starting with some of the most obvious. And in this case, one of our data teams attempted to safely deprecate a field that was no longer supposed to be in use, didn't realize that it had unintended side effects, as can often happen in a large, complicated platform. There was no monitoring on this particular field in our analytics tables. We caught it on the Anodot side because we're looking at the end of the day, how our customer spend is happening. And because this field was affected, we saw it in Anodot and we were able to catch it the same day. In this particular issue, one of our ad server teams released a change that altered a header field that our Singapore data center was using to place IP locations. It was a super edge case, but it affected the IP lookups of our Singapore data center only. And we saw this drop pretty clearly in our Anodot system. So we were able to reach out to our tech ops team, and again, that was resolved within a couple days. And again, these are all issues that if we hadn't piped this data over to Anodot, it's likely that it would have taken a much longer time to get detected, probably would have been raised by our customers. A bit more of a subtle detection here. So this was a single buyer buying on a single seller, both premium customers, and it was just a drop to, you could say, a new normal, but it wasn't normal. It was a misconfiguration on the buyer's end. So we were able to reach out and say, hey, we noticed that your spend patterns have dropped to a sort of a different range than they have been for the past several weeks. Is this normal? They looked into it. They found an issue with the bid request on their side. They patched it. Spend levels returned, which is definitely something that they weren't, definitely a level of service that they were not used to receiving from us. One more edge case. These transient spikes can be really, really difficult to pin down. A lot of times, if engineers see transient spikes in their system metrics, they're just going to be par for course, and they'll start ignoring them. In this case, we saw a pattern that each day at midnight, these spikes were happening. I was able to raise the problem to our optimization team, who found a really far edge case in our day parting system, and they patched it in the next major version. So these are all kinds of different use cases, and actually I'm going to add one off slide because I received one just a couple hours ago from one of our customers. One of their devs, they released a change to their tag code that goes on the pages of their publishers, and it caused an increase in blank advertisements. Essentially, if you were an end user, you'd go on the page and there would be an ad spot and you'd see nothing. We saw that spike within Anodot on one of their publishers' business objects. We reached out, and the same day they caught the issue before the engineer went on vacation, thankfully, and they patched that today. So that was a really fresh example that I wanted to share because the team was just really happy that we caught that for them. This slide is just a bonus that we got from the Anodot product that we were happy about, where when we're piping data into them in near real-time speeds, And they have this dashboard feature that's sort of modular, and you can set it up and customize the graphics that you see. What you're looking at right now is just a really quick attempt that I made to set up an example for some of our customer-facing teams of what you can do to monitor your customers and get a snapshot of their business activities. And some of the sales and services people have been really happy with being able to see their customers spend, their revenue, their patterns across different geographies and so forth, updating every minute or even less. So we've seen better service and cost savings from this. Proactively monitoring our large customers and catching these issues before that they do has often reduced investigation time for a lot of our services people, and obviously impacted our relationships as well. So there's a lot more that we want to do here to continue expanding our usage. So now we're going to get to more of the nerdier side of the segment. I'm going to talk at least at a high level about our integration with the Anodot team and how we accomplish that. So what we quickly found is that we needed a dual pathway to get our data into Anodot. One of those is what I mentioned before. It's near real time. It's a streaming integration that takes data from our ad server that gets directly passed into Kafka, which is an open source messaging tool. And our system reads from that and passes it to the Anodot API in the format that they desire by chunking the data up into 5-minute intervals. The round trip for that looks like about 10 minutes. So between the time the ad is served and it gets into Anodot and is analyzed for anomalies is about 10 minutes, which is a really good turnaround. And that's most of the data that we send. Some of the data that we send through a batch integration, which we pull from our standard analytics tables at Appnexus. We pull those in an hourly fashion and just chunk that up and send it over every hour. Because of the way that we sanitize data through our pipeline, that's about 3.5 hours of total latency. Now, the reason that we do that is because there are certain types of data inherent to advertising that you cannot do synchronously. So if you think about when an ad serves on your screen on the web, you see it, that counts as the ad impression, but whether or not you click on it, that's asynchronous. It might happen within a second, it might happen within a minute. But even further down the chain is a conversion. So if you saw an ad for a phone, you clicked on it, and you bought the phone, but you didn't buy the phone for 2-3 hours. That conversion event is asynchronous. So it's those types of events that we have to send over in batch fashion so that we can build in that latency and catch more of those events. Not all of them, but more of them. A little bit on the data that we do send, we found pretty early on that Anodot works most effectively when you send somewhat high-level data. So we break down our different fields one at a time, and we send over basically the equivalent of separate reports. So for a given customer, we're going to send one report on the buy side for advertiser. Then we'll send a separate report on the buy side for geo. So it's looking at the same swath of data, but it's cutting it by different fields each time, so that we don't have to break out the data by all the different fields at once and explode the number of rows that we're sending over. So that helps reduce the noise a lot, and also makes the data much more manageable. This is a snapshot of our architectural integration. I won't spend too much time on this. These will be available after if you're interested, and we can take more questions if we have fellow engineers who are interested in learning more about it. But essentially, we have a number of partitions in Kafka. We have workers that are reading from one or more partitions and shuffling on the keys that we are going to be sending over, which are those dimensions that we talked about in the previous slide. And then we have an aggregator that sums the data across 5-minute intervals, and lastly, a sender that posts to Anodot, basically at a constant basis. On the left here, these are just some system monitoring metrics we have of the streaming integration. On the left, we have 2 consumer metrics. One is the total seen. So we're looking somewhere between like 3 and 5 million every minute. Not the type of scale that we see on the ad serving level, but still a fair number in terms of messaging that we have to send over to the Anodot API, but they're able to handle it with no problem. And on the right side, we have metrics for the aggregation side of the integration, where the metrics have been chunked by those dimensions, but now they're aggregated and finally they're sent. And the bottom ones are topic lag, which is a concept in Kafka. If you think of it as a giant messaging queue and you're looking at whatever the newest message is, this is how far behind are we in terms of what messages are available. This is just a simple screenshot showing how our batch integration works, because it's very straightforward. It's just a script that runs every hour. It logs a bunch of data, it chunks up the report and sends it. And at the bottom, you can see there's total runtime that we log just to make sure that we're staying on track and we're not getting behind. In doing this integration with Anodot, we had to think about governance of this whole process. So on the left, you can see this is basically just roles and responsibilities. On the left is the Anodot team. They're responsible for the maintenance of their systems, pretty much everything that you would expect the Anodot team to do. They interface with my team, which is the Anodot dev team. We assemble best practices. We assemble specific Appnexus usage of the product, user management, etc. We interface with some of our customer-facing teams who are on the right of the orange box. They're responsible for the maintenance and the usage of the actual alerts and dashboards, and then communicating with the customers directly when needed. So what's next? As I mentioned, there's a lot more that we would like to do. At the moment, we are on the cusp of releasing an internal interface, which is an application that essentially opens up Anodot. It provides an interface for any internal engineering team to send whatever data that they want to pipe over to Anodot's machine learning, however they like. So we essentially we'll meet with the team, we'll ask them what their use case is, we will confirm if it's a good fit, and then we'll talk about how much unique data that they need, the cardinality, the number of unique metrics that they need in total, and the speeds that they're looking for. We'll give them an allocation in our app, and so long as they conform to certain naming conventions and those usage requirements, we essentially ship over the data that they send without question. Other feature plans. One thing we'd really like to do is send release events. Those can get correlated with alerts in the Anodot system, so we'll know immediately if an issue that we're seeing has to do with some kind of release. That hasn't happened for a while, but it's something that we definitely want to have covered. One other option we're looking at is to monitor, to actually introspect the very usage of our objects in our system that our customers use. So how many distinct advertiser objects they have in our system, how many do they create a day, how many do they delete, how many have been sitting around and unused, not spending, etc. Give us that kind of introspection to see if our customers are using our system in an optimal way, or maybe there's a way we can increase our usability there. And some optimization ideas we had to automatically create JIRA tickets upon detection of an issue, because Anodot supports webhooks, and automatically run a contextually relevant report on detection. These are just ideas for automation, and the sky is kind of the limit here with what you can do with hooking in different data sources. Okay, so that does it for me. Thanks for listening, everybody, to how Appnexus uses Anodot, and I'm going to pass it off to Ira.
Thank you, Tyler. So thanks, everybody, for staying and listening. So we're on to the third part of this webinar, and what I wanted to talk about in the time remaining, and I'll leave a lot of time for questions as well, is actually how do we make Anodot? What's the component making up Anodot, both from the product side and the anomaly detection side. So basically, when we think about our platform, we the description of it is autonomous analytics platform. So what does autonomous analytics platform mean? Basically, the mission statement that we have at Anodot is to create an autonomous way of doing the tasks that you do with your BI manually today, but leverage all the machine learning technologies and algorithms to actually automate a lot of these processes so it can scale. Because the manual way just doesn't scale and is not good enough for today's purposes in many, many businesses. So what makes up the anomaly detection platform? It has two parts, the autonomous analytics platform. The first part is the detection part. This is where you're finding out what is happening right now and dealing with it. So anomaly detection is the technology and the methods that let you detect that there is something going on right now that you need to pay attention to. And why is anomaly detection the right thing? Because this is the strange things are the things you need to look after. The second phase of the autonomous detection is root cause investigation. And here, there's a set of algorithms to help you identify the root cause as quickly as possible. And that's super critical as well to stop the bleeding of the detected anomalies. The third part is looking at changes in trends and how those affect your business. And it's at the boundary, actually, between the prediction and the detection. So detecting that there are trends also implies you're doing some forecasting into the future. And really, that's another service that we see in the autonomous platform, autonomous analytics, is being able to forecast what is going to happen with your key KPIs. And you want to forecast both your financials of the company, so you can plan your budgets and do everything around that. And there is more operational type of forecasts, which are more around supply demand. So whenever you have a scenario when you need to meet some demand, if you're in e-commerce and you're selling goods, you have to make sure you have enough inventory of the goods. Or if you're a ride-sharing company and you're selling rides, you have to make sure you have enough cars on the road to meet the demand. So forecasting that demand is really important so you can make sure you have enough supply. Of course, the last part of that journey is to help you impact the future. So you can ask yourself, what if I added more dollars to my marketing campaign? Would it increase my demand? And if you can do forecasting and you have models for doing forecasting, you can start answering those types of questions. So these are the basic questions that we are building in our autonomous analytics platform. And you heard from Tyler the detection and investigation part of it. And what I wanted to talk about is double click on that and talk about the anomaly detection and investigation part in terms of the technology behind it. So basically, the purpose of anomaly detection is to tell you at any given time, is my business on track at any level and any granularity. So if my business is very small, you can do it with your eyes on your Grafana dashboards or all sorts of dashboard visualization methods. But if your business is large, like Appnexus, where you have a lot of partners and a lot of publishers and a lot of campaigns, and you want to answer all the questions about all of them, you can't hire enough people to eyeball all the data. So this is where machine learning comes into play, in particular anomaly detection. So anomalies are all the unknown situation that you're not aware, you wouldn't be aware of otherwise, or you would stumble upon accidentally, that if gone unignored will actually leak business from your company. So when you come to build an anomaly detection system, there are several design considerations. So this is just like any other product, and especially a data-driven product, you have to think about what is important for what's the value that you're bringing, and what's important in terms of the design to make sure you meet that value. So accuracy and robustness are two obvious things from any machine learning based system. So you want to be accurate, you want to be robust. Nobody doesn't want to be that. But what does accuracy mean? Which accuracy is more important? So what we have seen from the many customers is that false positives are really people are very sensitive to false positives, and the reason is false positives cause them to do work that they don't need to do. And it's important to catch all the issues, but if you miss a few, you'll pick them up afterwards, a bit later. So you don't want to miss anything, but if you're flooded with false positives, you're going to start ignoring everything in the system, and that's what happens with a lot of monitoring systems. So to be accurate, to minimize false positives, you have to be robust to various types of signals. You have to be robust to the ever-changing dynamics of businesses. So we're not monitoring something static. We're not looking at the measurements from a static closed system that never changes. That businesses change all the time, and the data changes accordingly, and you have to be robust to that. Scalability is not just about being able to collect a huge amount of data, but it's really about being able to analyze a huge amount of data and in real time, and analyze it with no configuration. So if and I won't give how many metrics Appnexus has, but we have other customers that have millions of metrics that they send into our system. We cannot, and they cannot, specify anything about that data other than giving us the data points and telling us this is the measurement of revenue in a certain country, for example. We can't ask them questions about the data, about its behavior. Does it have seasonal pattern? Everything has to work out of the box automatically, and the outcome also has to be consumed by non-data scientists, by business analysts, product managers, and so on. So zero manual configuration, no data science required, and at very, very high scale. Not very simple, but it has a lot of implications on how you build the system. The last piece is completing the picture. So detecting that there are issues is great. If you don't help with the investigation part, it's only halfway. So being able to help the investigation part of an issue by isolating and correlating everything that is related to each other, so the user can use that to help quickly identify the potential root causes and go and check deeper, that's really important. So these are the main design considerations. And they're different from an anomaly detection system that you might build for an engine of a car that was not going to change a lot or doesn't have a lot of data, or to other types of systems. So these are the ones that we saw are really needed for doing it for businesses. So how did we build this? Using these, basically going through these 5 main steps. So our system is an unsupervised learning system. So everything has to be done in an unsupervised fashion with no help from our data science team or the customer. And why? Because of the volume of the data, because the knowledge is not really even there in most cases. So the first step is being able to collect and analyze all of the data all the time. So analyzing all the data, I'll touch on what does that mean. From the design perspective and the system and the algorithm perspective. Then once you collect and start analyzing the data, you want to build for every metric that comes into the system what is normal about it, and then being able to rank and score and classify the abnormal behaviors as well, because they're not all equal, and be able to correlate between all the different anomalies that you might find. So the investigation becomes easier. You make it concise. You say, my revenue is related to my API errors and related to number of users going down and doing a certain flow. So knowing all that together really helps with investigation. The last part, the 5th step, is actually getting feedback from users and improving the algorithms and their behavior using that feedback. But our experience is you can't assume the feedback will be given. It has to work with zero feedback in a completely unsupervised fashion. If the system if you want a system that is useful. So the first step, a little bit of double click. So the first step is first to integrate with a lot of different sources. I'm looking at a business. It's not enough to look just at the web analytics data from Google Analytics or Mixpanel. It's not enough to look just at data from my logs, if they come from Splunk, and it's not enough to look at my application data, and it's not enough to look just at the business high-level data that comes from my events, for example, using a real-time stream like Kinesis. So you want to integrate with all the different sources that make up the picture of what your business is, so you can, A, detect the important things, and then when you detected them, correlate all the related pieces of information that will help you investigate it. So if you just choose your web analytics, your investigation power will be limited. If you just choose your logs, then your investigation power of something detected in the logs will be limited to that source. So that's really critical. Now, we want to detect anomalies in all of the data. We don't want to choose, to pick and choose subsets of the data where we'll run these algorithms on and find anomalies on. And why is that? This is anomalies. They happen where they happen. This is the whole thing of not knowing what you don't know, finding the unknown unknowns. That's, all these marketing buzzwords are really all the same, saying a simple thing, that anomalies can happen anywhere, and if you don't detect it on all of your data, then you're basically covering a piece of your business and hiding it from this system. But it will come back to bite you, because the anomalies there will cause other anomalies somewhere else. You'll have a leakage, and things will start misbehaving, or you'll miss really important opportunities. So you want to detect anomalies on all of the data that you have. And now that if you agree with that, there are really hard considerations to think about when you're doing it. Scale. So you have to have very parallel algorithms if you wanted to scale to the scale of businesses today. To give you a sense, Uber, which is not our customer, reported having around 500 million different time series that they collect all the time around their business and operations. And if you wanted to analyze 500 million metrics, then you have to have something very, very fast and parallelizable. You want to minimize your I/O. So if I take the data, store it, and then pull it out, I lost a lot. I mean, my storage will have to be very, very expensive, and that's really hard. You want things to be real-time. We're talking about businesses and being data-driven. You don't want the answers to come a week later. You want them to come when they happen. So retrospective analysis is nice, but it's not good enough. So you want you to detect as the data arrives, not wait, not batch. You want to update your models with every data point. That helps with being accurate and adaptive. So basically, batch algorithms are a bad choice if you wanted to do this at scale for all the data. So you require, what you need is online learning algorithms, online meaning that they update themselves, what they learned with every data point that comes in, running on the data stream in memory, not pulling data out of databases after the fact. All of that will make it hard to do anomaly detection on huge amounts of data and in real time. Once we determine that we need online algorithms, now we can go to and talk about how do we learn what is normal. So there are many considerations for learning the normal behavior. So first of all, what is normal behavior? So a normal behavior is manifested visually as what you see here, this baseline sleeve, as we call it. So the actual measurements that are normal are within the bounds of normalcy that the normal model determined for every point in time. And when it comes out, it becomes an anomaly. So once you have this range and you can predict the range of the next data point, then when it comes, you can check whether it's an anomaly or not based on that. And if you trust your normal model to be accurate and good and robust, then the anomalies, you can trust them as well. So there are a lot of considerations around how do you build a good normal model. There in the literature, you can find a lot of work around both temporal models and also deep learning models. A lot of it is good for certain types of signals will work okay on smooth or stationary signals that are things are regularly sampled that have this very predictable behavior. But the reality is that there is a lot of other types of metrics that we collect, and from all our customers, we see a lot of all these types. It's not that this is, just one vertical has this type and another vertical has another type. And you have to have different algorithms for different types of data. Otherwise, you end up with a very non-robust system. So when we built Anodot, we realized we have to build a classifier that will choose the right algorithm for every data type, and we have to classify these data types. And that's not simple. That's work that you must do by looking over a lot of data and realize what you actually need. So a lot of considerations for normal learning, things from signal type to distribution to whether they have a seasonal pattern or not, and what type of seasonal pattern, and being able to adapt to changes. And you have to have an algorithm of adaptation during normal times, and change the algorithm from how it behaves when there are anomalies, and how do you behave after anomalies. So all of these will have implications on whether you detected the right things and whether your normal model continues to be good following anomalies that happen in the data. So I'm going to skip to step 4, which is the correlation, which is basically the step that helps you do root cause investigation. What does it mean? If I now get alerted that the amount of payments are down abnormally, I want to be able to see that other measurements, other metrics that help me explain why these payments went down. So in this example, if I see that my payments is down and my API errors to a particular payment provider went up, that actually gives me a very strong indication that the errors to the payment provider are the root cause of this number of payments going down. Now, when I have millions of metrics that I'm measuring, it's not just amount of payments, it's amount of payments broken down by the category of the payment and it could be the country and the OS and so on. I end up with millions of these. How do I know what is related to what? So nobody can actually specify this manually, or it's a very, very hard task to do. And it's always a very short-lived task because once you finish it, you have to go back and redo it because things change. So our approach is to learn this, to learn what is related to what. And when we know what is related to what, we can actually group them and correlate them to help you find the root cause. So what are considerations for root cause analysis? So false positive correlations is really bad because if I tell you that your API errors is related to the drop in purchases and now it's not, then I threw you off to the wrong start. So I threw you off to a very bad investigation. So just looking at whether things correlate in time is not enough. Linear correlation algorithms, I can save you the trouble. If you ever try it, don't try it. It doesn't work. Too many false positives if you're talking about high scale. So you really have to look at the data at multifaceted, look at it as various, what are the cues that are in the data that help you say whether two things are related, and not just whether they look the same graphically. So we have a few of these clustering algorithms based on different facets of the data. Scale is also important, just like any other step. If you're talking about hundreds of millions of time series and you want to find the relationships between all of them, and you try to run some clustering algorithm, it's going to be very, very slow. If you had to run it only once in your lifetime, you can pay the price. But things change. Like I said, businesses change. Things need to adapt. You have to recheck it and recheck it. So we actually run these algorithms once a day, not once in a blue moon, because we know things change. So you have to take complex and very expensive algorithms and make them fast. And that requires some data science expertise to do that. It's not just off-the-shelf algorithms. The last bit of that is really usability. So if I can be very, very smart and find all the anomalies and all the related correlations between things, and if I don't have a good way to present it to you, as a user, then you're not going to understand anything anyways. And so in many of these cases, these anomalies and these investigations are done by people and not by machines. So it has to be visually clear what are we showing and how do you do the investigation. And that's a lot of work in terms of the product UX. So if you want to see our system, if you want to see how it looks like, if you want to join as part of the customers, just like the example customers that we have here, then call us up, send me a note. I'll be happy to show you a demo of it and how it looks like, and show you all these concepts in reality, just like Tyler showed about their Appnexus journey. So thank you, and I think I'll stop here for questions.
Thanks, Nick, Tyler, and Ira. We are coming up against the hour here, so we are going to have to cut our Q&A session. But please feel free to still submit your questions, and we will get back to you, all of them via email, so you can submit them still in that questions box. That concludes today's webcast. As a reminder, the on-demand replay will be available on Bright Talk soon. On behalf of Anodot and 451 Research, thank you so much for attending, and have a great day.